Okay, this next lesson is going to be how to factor. If there is anything in this lesson that you're not sure of, you need to come and get some extra help. Factoring is the #1 technique that we're going to use throughout this entire course, and you are going to be expected to know how to do this. If there's something you don't know, let's work on it together, okay? You can't just let this go. The first type of factoring we're going to look at here is how to factor out a monomial. Okay, so nomial means term. Nomial means term. Sometimes they call this the GCF, the greatest common factor. Okay, so you're taking out mono, which means 1. I'm going to look at each of these, and I'm going to take something out. Okay, so I can take out the number 2. They both have a 2. The greatest thing you can take out. How many x's can I take out? It seems like they both have 1 x. He doesn't have 2 x's. Can I take out a y? No, because he doesn't have any. Okay, so after you decide what the greatest thing is, you're going to take it out. So if I take his 2 away and I take his x away, that only leaves this first term with an x. Minus sign. 8 divided by 2 is 4. I factored his x out. All he has left is a y. Okay, so I believe that this is factored form. Okay, we're going to go ahead and check a lot of these here. Okay, so I always want you to check. I'm going to distribute it back in and see if that gives me the problem. Does 2x times x give us 2x squared? That's perfect. Minus 8, and then there's an x and a y. Okay, so it looks like that is indeed the correct answer. This is factored form. Okay. So last time we did multiplying, and now we're doing dividing. Okay, and dividing is called factoring. Divide out is called factoring. All right, from this next term, what's the biggest number they all have that I can take out? I'm going to have to listen to the smallest guy and take out a 3. How many x's can I take out? I've got 3. I've got 2. I've only got 1. All right, then 1 it is. Okay, I don't have any more than 1. All right, now we're going to take a look at each term. If you start with a trinomial, we're going to end with a trinomial. We're still going to have 3 terms right here. I took away his 3. I took away 1 of his x's. I divided out 1. He still has 2 x's left. Minus sign. 9 divided by 3 is 3. And that leaves us with 1x. Plus sign. 6 divided by 3 is 2. I took his x away. He has no others. I believe this is factored form. Okay, let's go ahead and check. And to check, we're just going to go ahead and distribute it in. Okay, some people just check right here. 3 times 1 is 3. And then that makes a total of x cubed. Minus sign. 3 times 3 is 9. X times x makes x squared. 3 times 2, that's going to be 6 with 1x. Does that check? Great. Okay, so that's how you take out a monomial. Okay, second type of factoring. How do you factor a difference of squares? I'm going to divide up my paper here just so that I don't smush these 3 together. Okay, so when you have a difference of squares, I think we looked at this when we were multiplying, it's going to have 2 terms. Okay, sometimes people call this a perfect square, difference of perfect squares. Okay, so that means that the thing in the beginning is a perfect square and the thing at the end is a perfect square. Okay, so this is how you do it. It's nice and easy. You draw 2 sets of parentheses. Okay, I take the x, I split it up into x and x. I split him up evenly. Is x times x squared? Yes. Okay, how can I take 4 and split it up? What you're doing is the square root of 4, and that's 2 and 2. Okay, now one of these is going to get a plus sign. One of them gets a minus sign. All right, and then how do you check something like this? Oops. You multiply it out, right? X plus 2 times x minus 2. So let's FOIL it out. The first would be x squared. The outers would make minus 2x. The inners plus 2x. And the last minus 4. 2 times 2 is 4. The middles cancel. Okay, and that's exactly what I needed to happen. All right, so when you're doing a difference of squares, okay, you have to make sure that one of them gets a plus sign and the other gets a minus sign, and then these have to be identical. Okay, and what do you do to that? Okay, you square root it. Square root the 4. Let's try again. Let's go ahead and, is this a perfect square? I believe so. Okay, take 4 x's and split them up evenly. X squared, x squared. How about 1? What's the square root of 1? Plus and minus 1. Okay, now don't forget to put 1 plus sign, 1 minus sign. Okay, well this is really good so far, but I think we can go more, okay, because 2 x's can factor. How about this one? Can this one factor more? That's x squared. No, okay, because difference means it has to be a subtraction sign. If you don't see a subtraction sign, you can't factor it further. So that one's going to stop, okay? But this one over here, let's just change colors for people, okay? This one right here can factor again. X squared can split up into x and x. 1 can split up into plus and minus 1, and that is how you make it. All right, this last one here also has like a little trick to it. Okay, so here's the note. The note means keep factoring, okay, as much as possible. As much as possible. Okay, so how do you know when to stop? Okay, if you have a plus sign, stop, or if you don't have a power. Okay, I can't factor that one, even though it's a difference. He only has 1x. Right here, I don't think 3x squared is a perfect square. I don't think 75 is. So what are we going to have to do here? We're going to factor out a monomial. In fact, let's take out a 3. If I divide by 3, that's x squared, and that's a 25. Oh, this is looking really good. This is looking really good, okay? This looks like a difference of perfect squares. So how does this problem factor? Don't forget to type the 3. X plus 5 and x minus 5. Okay, and don't forget to write the 3. If you multiplied this all back out, it would work. Okay, factoring perfect square trinomials. How do you factor those? Okay, remember, perfect square trinomials are trinomials that came from the same binomial 2 times. Okay, and so the trick to doing these, they're going to look a little bit like this. Okay, x squared is x and x, and then 49 is 7 times 7. Okay, now this is a plus 14. Since that's a plus, we're going to put a plus and a plus. Okay, and let's go ahead and show you how this checks. Okay, how does this check? X times x makes x squared. The outers make plus 7x. The inners make plus 7x. And then the last make positive 49. So a plus 7x and a plus 7x makes a 14x. So sometimes when people have problems like this, this is how they check to see if they do indeed have a perfect square trinomial. They take this middle term, they say, how does this split up evenly? So if I take half of that, 7x and 7x, okay, and this is x and x, and that's 7 and 7, do I have a 7x and a 7x? Yes, you do. Okay, and if this sign is a plus, then these signs are gonna get a plus. All right, let's do this last one here. Okay, I'm gonna tell you this is a perfect square trinomial, but there is a way to check. Okay, so first of all, if I take that 12x, negative 12x, and I split it up, that would be negative 6x, negative 6x, half and half. Okay, so how does this work? If we take the 9x squared and I put 3x and 3x in the front, so you take the square root of him. And then let's split up the 4 into 2 times 2. Okay, so how is that going to work? If this is a minus sign, these both get minus signs. You can't put a plus and minus because then you'd only have 2 terms like these perfect square trinomials up here. Okay, it's got to be the same sign. let's go ahead and check. Let's check, okay? 3x times 3x is 9x squared. The outers make minus 6x. The inners make minus 6x. And then the last plus 4, okay? So these middle terms right here do indeed combine to make minus 12. Okay, perfect square trinomials. Factor by grouping. This is one of my favorite kinds of groupings, okay? How do you know you're going to have to do factor by grouping? This is only when there are 4 terms. When you have 4 terms, okay, you get to do some factor by grouping. All right, so what we're going to do is we're going to look at the first 2, call them a group, and then I'm going to look at the second 2 and call them a group. All right, now some people accidentally start putting parentheses here, and that is bad. Okay, if you need to underline like I did to see group 1 and group 2, that's fine. Okay, but the problem with putting parentheses, okay, where's the pencil? If you were to put parentheses like this, okay, do you see how you just turned it into a multiply problem? That's wrong. Okay, you can't change the problem. Okay, so you're only allowed to kind of do some underlines, not parentheses. That's for the final answer. Okay, what can I take out of these 2? They both have 2 x's. Okay, so from the first 2, I'm going to take out 2 of his x's and take away 2 of x's. Okay. Now, from the second group, I'm going to see what do they both have. And I really don't have anything, but I have to write something here. I have to write plus or minus. The only thing I really can do here is put a plus 1, and then I'll put parentheses. So taking out a 1 really doesn't change him at all. Okay, now let's take a look at what we have. If I distribute this back in, x cubed minus 4x squared plus x minus 4. Do you see how there's 2 terms here and 2 terms there? Okay, you have to put something there. All right, here comes the final answer. Okay, you write 2 sets of parentheses. Okay, the first set of parentheses are going to be the things that you took out. X squared plus 1. I like to call these the leftovers. Okay, and then the second set of parentheses is the thing that matched. X minus 4. Now, what do you do if they don't match? You go and try again, okay, or maybe the problem just can't factor. All right, so let's put some notes here. Okay, right here, super important. Okay, we must write plus or minus a number. Okay, you have to put plus minus a number right there. Okay, and we must have matches. We must have matches. If you don't have matches, it didn't work. Okay, where am I going to check this? I guess I can check it over here, right? Check. All right, let's show everybody how multiplying these out makes the 4 terms. X squared has to get multiplied by x. Then x squared has to get multiplied by minus 4. Then the 1 has to get multiplied by x, and then the 1 by negative 4. Okay, so it does check. You take 2 things out of the first 2 terms, plus something out of the second 2. Okay, you have to put a plus here. If you didn't, it would say times, 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 and that's not correct. Here is where the parentheses go. Let's do it again. Let's look at the first 2. Okay, here's group 1. And let's just cover up group 2. Don't even look at it. So what are we going to take out? The biggest number I can take out from 10 and 4 is a 2. And then the letter they both have is a y. Okay, so that leaves me with parentheses. 5x plus 2. Okay, is that correct? Let's just see if I distribute it back in. Does it make those 2? Okay, good job. Second 2 terms. Okay, I'm just going to cover this up. Don't even look at this. What can you take away from those 2? Okay, if it starts with a negative, we have to take out a negative. They both have a negative. And then let's take out a 3. Okay, so let's just put a little note here, okay? If it starts with a negative, factor a negative out. Factor a negative out. If it doesn't start with a negative, don't worry about it. Okay, so that's going to leave me with a 5 and an x. I factored out his negative, so now he's a positive. 6 divided by 3 makes a 2. Okay, so if I distribute that back in, we're good. Notice you have to have plus or a minus number. Now, is this problem working? Okay, and I can tell you yes, it's working because I see matches. Okay, so we're ready for our answer. Okay, put 2 sets of parentheses down. The first set of parentheses are going to be these leftovers, the things you factored out. And then the other set of parentheses is going to be the matches. Okay, just 2 sets of parentheses. Okay, we don't write 3 sets of parentheses, just 2. Okay, okay, great job. All right, what other kind of factoring are we going to go over here? Okay, factoring trinomials by hand. And this is where people say they need the most amount of practice. So I'm going to give you lots of practice. I'm going to show you a variety of techniques that hopefully you've seen before. Whatever one works for you, we're going to go with. Okay, so the first one is called an MA table. Okay, it's called an MA table. MA table. So this is how it works. Okay, here's the multiply, here's the add. Okay, so to get the multiply numbers, I take the leading coefficient 1, multiply by -2. -2. Okay, that's the multiply numbers. Now the add number comes from the middle, which is a +1. I'm trying to think of numbers that multiply to a -2. In fact, let's just think of 2. Forget about the negative for a second. The only way to make a 2, I think it's got to be 1 times 2, right? Okay, now let's think about the negative. How am I going to put a negative here? Multiplies to -2, but adds to a +1. So I know one of them needs to get a negative. Not both of them, because if I give both of them the negative, it would turn positive. If I put the negative on the 1 and then I add them, that works. Okay, so most of your time is going to be spent here trying to figure out the numbers. Once you have the numbers, okay, what do we do with them? We use these to split the middle, term. Okay, so we're going to come back over here. We're going to write down the first term. We're going to write down the last term. Okay, and we're going to use these numbers to split the middle term. So instead of plus x, I'm going to write -1x plus 2x. Doesn't that indeed add up to +1x? Okay, now what have we done? We've just turned this into a 4-term factor by grouping problem. Okay, it's just like our last one. So from the first group, let's take out an x, and that makes x minus 1. Okay, from the second group, it starts the positive. Okay, so I'll take out a positive, and I'll take out a 2, and that leaves him with x minus 1. Okay, is it working? Yes, it's definitely working because I see duplicates. So one of the sets of parentheses is going to get the x plus 2. The other set gets x minus 1. Okay, a couple questions I get sometimes. Does it matter which order you put these numbers in? If you put the 2x first, doesn't matter. Does it matter what order I put these in? Could I write x minus 1 and then x plus 2? Sure, it doesn't matter. Okay, these are equal. Those are the same. Could I put the minus on the 2? No, you can't do that because now you're switching things around. But it doesn't matter which binomial you put first. Okay, let's go over this again. Let's do the MA table, but sometimes people actually do it with like a crisscross or a wheel. Okay, it's the same technique really. Okay, so we're going to take 1 times 24. okay, and we're going to make 24. So here's where the multiply number goes. And then the add number is 10. The add number is 10. And I'm trying to think of two numbers that multiply to 24. Should it be 8 times 3? No, 8 and 3 don't add to 10. 12 and 2? Ooh, that might work, except I would need a negative, and that doesn't work. Oh, I know. 6 times 4 makes 24, and 6 plus 4 makes positive 10. Okay, once you have these numbers right here, yay, we have the right numbers. Okay, this is where most of the work happens. Now, what do we do with those numbers? Okay, we're going to come over here, and we're going to split the middle. So x squared, okay, you just write like that. But instead of 10x, we're going to write plus 6x plus 4x. And then don't forget to write plus 24, okay? Now you do factor by grouping, okay? We've got group 1, and we've got group 2. Remember how we said you have to underline? You don't have to underline, okay? But you can't put parentheses here. Parentheses are for the end. Okay, so from this first group, let's take out an x, and we have x plus 6. From this group, let's take out a positive 4, and that gives us x plus 6. Is that working? It is working, okay? So the final answer, here's where the answer goes, okay? Now you put parentheses. It's the quantity x plus 4 times the quantity x plus 6, okay? So there's our final answer. And how do you know if your answer is right? Okay, it's not a guessing game. You can always check your work. Okay, on a test, all you have to do is multiply these two binomials. Does it actually make the problem? If you want an A, you could tell if it's right. X squared plus 6x plus 4x plus 24. Do these combine to make 10x? Yay, we got it. Okay, you can even check just by multiplying with your finger, okay, and doing it in your mind, but you should definitely check your factor. All right, let's do it again. Let's do it again. I'm going to go ahead here and do the MA table. You could do the table or the wheel, okay. 2 times negative 5 is negative 10, and the add number is negative 9. Okay, now you don't have to worry about the negatives just yet. Let's think about the numbers that make a 10. Well, it's either 1 times 10 or 2 times 5. But they have to add to 9. Add or subtract, right? So I know it's not these. Now I'm going to worry about the negative signs. To multiply to a negative, one of these gets a negative, not both. Which one should get the negative so that they add to negative 9? Yeah, the 10 is going to get the negative. Okay, so I found the numbers. What do I do with the numbers? You split the middle. Okay, so 2x squared goes first. I'm going to write plus 1x and then minus 10x minus 5. If these were y's, I'd put y's. If these were m's, I'd put m's. If these middles were x squareds, I'd put x squareds. Okay? All right, now let's take a look at the first group. What should I take out? I'll take out an x, and that leaves me with 2x plus 1. From the second group, if it starts with a negative, take out a negative, and then that will leave us with 2x positive 1. Did it work? If it doesn't work, go back and check your work or check your numbers. Okay, if it doesn't work, it's not coming out right. We have x minus 5 times 2x plus 1. Okay, you can FOIL that out to see if it works. All right, let's go ahead and do another one here. The multiply numbers, negative 36, and the add number is a 5. Okay, everybody has to do this work, whether you write it down or just do it in your head. Everyone's doing this one way or the other. Okay? I'm not going to worry about the negative. I'm just going to take a look at what numbers make a 36. Okay, and you can be systematic about it if you want. Some people like to do that. 1 times 36, 2 times 18, 3 times 12, 4 times 9, not 5, 6 times 6. Once you get all the way to 6, okay, you've already got the other ones. Okay, so we have all the combinations. Which ones add or subtract to a 5? Yeah, it's got to be the 4 and 9, right? Okay, so I found the numbers, but now let's think about the negative. One of them gets a negative. Which one? The 4 gets the negative. Okay. Now here's a trick I'm going to show you. Okay, and sometimes people, they use this trick way too much. You can't do it all the time. Well, let's write this down, okay? If the leading coefficient is 1, okay, you can skip to the end. What? Yeah, you can skip to the end. Okay, the leading coefficient is a 1. Okay, let's go ahead and skip to the end. Okay, how do you do this? I know that it's going to be x and x because the leading coefficient is 1. And what are the numbers that are going to go here? The ones from the table. -4, +9. All right, but please write down this hint because people do this all the time and they mess it up. This problem over here, we could not do that, okay? Do you see these numbers on the ends? No, you're gonna mess it up, okay? Because there's a leading coefficient. Here, let's show you why. Let's go ahead and check. X times x is x squared. X times 9 plus 9x minus 4x minus 36. And then this makes, yep, it definitely checks. Okay, but please don't do this all the time. Okay, number 14. Hang in there, guys, we're almost done. Okay, this is a really important lesson. Sometimes what you can do, okay, is a technique called guess and check. Now, guess and check is great. Some people love it. They use it all the time. Some people hate sitting there and guessing and guessing and guessing and wasting all their time. All right, I know that this is going to be a binomial, okay? And I know that 21x squared is probably 7x times 3x. It's the only way to make a 21. I don't think it's 1 and 21 because these are small numbers, okay? Now, how about the lasts? I know that whatever I put here, I know that something times something has to make a 2. Okay, so when I FOIL this out, the last have to make a 2. The question is, does the 1 go here and the 2 go here? Well, I don't know. I'm going to have to check. Okay, so here's where the checking part comes in. Sometimes you have to do a lot of erasing. I guess we should call this the guess and check and erase method. Okay, so let's see. Is this going to work? 21x squared. The outers make, I won't put some signs. I'll just figure those later. 14x. The inners make 3x, and then that's a 2. So is this going to make an x if I add these or subtract these? Nope, it's not working. All right, let's switch. Let's put the 2 here and the 1 here. Okay, now what changes? Not the firsts and not the last. Okay, so it's really the middles that we're checking. Checking the middles. Let's add that. Guess and check the middles. Okay, it's the middles that you really, really, really have to check. Okay, so if I do that, let's erase this. My outers are now 7x, and my inners are now 6x. Is that going to somehow make a 1? I think we're getting closer, right? We're getting closer. So I'm going to lock in the 2 and the 1. But now I got to think about the plus and minus signs. I know one of them has to get a minus. And I know that I want this to add up to 1. So plus 7 minus 6 would be the way to go. So let's put the plus on the 7 and the minus on the 6. Okay, and now it's time to check. All right? So let's see. Does 7x minus 2 times 3x plus 1 actually make the problem? 21x squared plus 7x minus 6x minus 2. And that, oh, does indeed check. It works. Okay, so then you could box up your answer. The guess and check technique, some people really like, all right, but you got to do a lot of work. Okay, and if you don't like doing work and erasing work, then maybe just having a technique that you could follow would help. Okay, let's go ahead and do this last one. At this point, I would ask people, how do you want to do it? And I think people would just want to go ahead and make a table. Okay. The problem with 6, is it 2 and 3, or 3 and 2, or is this 2 and 3, or 3 and 2, or is it 6 and 1? It's too many things to check, too many possible combinations. So in terms of my multiply number, 6 times 6 is 36, adding to 13. Okay. So we could sit here for a while and we could think about these. Okay. Or we can maybe be systematic. Okay. Systematic gets the job done quickly. Is it 1 times 36? Is it 2 times 18? Is it 3 times 12, 4 times 9, or 6 times 6 to make a 13? What are the numbers? You got it, 4 times 9. What do I do with those? I'm going to split the middles. Split the middles. 6x squared. My first middle is going to be a plus 6x. And then another, that's a 4. 4x, and then plus 9x, plus 6. Okay, from the first group, what can I take out? Let's take out a 2 and an x, and that leaves me with 3x plus 2. From the second group, let's take out a positive 3, and that's 3x plus 2. Is it working? It's working. Okay, final answer time. Final answer time. The leftovers, 2x plus 3, and then the matches are 3x plus 2. Great job, guys.